Bismillahirrahmanirrahim. Starting with the name of Allah, the Merciful, the Beneficent. I hope you are all fine and in good touch of health. And as all we know, we are approaching the assessment exam period, and now we are also in a process of finishing this the remaining part of epidemiology, so that if some of the student needs to revise it, he will be or she will be comfortable to do that. We have been looking for the final topic of the epidemiology, and that was sampling techniques, and we saw that first of all there are the probability sampling, and then is the non-probability sampling. We concluded that wherever is possible we will go for the probability sampling, and where not possible or we are bound to go for the other way of sampling, then we shall go for the non-probability sampling. Probability sampling, we saw there are 4 types: simple random sampling, systematic random sampling, stratified random sampling, and finally the cluster sampling. And now the non-probability sampling. So non-probability sampling is the types of non-probability sampling. The first of all, the convenience or the haphazard sampling. Convenience, easy. Convenience, wherever we are comfortable. So this is done according to the convenience of the investigator, and whoever is accessible is included in the study. This is a potential threat to the validity as far as the sample purity of the sample or the representative sample is concerned. So the sample is not representative of the population, may not be, I must say, may not be representative of the population in this stage or in this type of selection of the sample. Then is the, of course, among the non-probability sampling is the judgment sampling, purposive sampling. Again, it is a biased type of sampling. Again, it's I can say, the validity can be doubtful. Not the word of bias may not be correct, but the validity may be doubtful. So here one decides the purpose which one wants to, as informant or a community, to serve. Those who are selected for the study have some sort of specialized expertise, experience, knowledge, or exposure. So this is same potential threat to the validity again. So again, the validity of the sample will be threatened. The selected persons are the ones who have got certain potential to expertise or experience to answer the questions, and that is why those are selected. Others are illiterate, others are villagers, they do not give you time, but the ones who give time may be the biased ones, or maybe the potential threat to the validity is there. So first was among the non-probability sampling, convenience or haphazard sampling. Then among the non-probability sampling, second is the judgment sampling. Third is the quota or proportional sampling. Again, the quota system, population divided to subpopulation, and from the subpopulation, the representative or the presenters are the active people, are those who have been selected by the subpopulation themselves, by the investigator, by the researcher, have been selected and included. So the decision is taken on the subpopulation of the interest and on proportions of the subpopulation in the final sample. Quota sampling resembles stratified probability sampling with an important difference of non-probability. So every member of the population does not possess the equal chance of being selected, but it is from the quota. As is the quota for the 6 provinces, maybe in a cricket team, if we have quota from all the 6 provinces of the country, then maybe the person from Gilgit-Baltistan, the player playing in the 11 may not have those capabilities as a person who has not been selected in the team from Punjab because of the quota system. In the quota, the selected ones are better ones, and those who are not selected may be better from the other quota or other subpopulation or other province being selected. Same then is the snowball sampling. First was the I said haphazard sampling, then second was the judgment sampling, and third was the quota sampling, and fourth is the snowball sampling. Snowball sampling is a sort of a chain referral sampling. The researcher locates one or more key individuals and asks them to name others who would be likely candidates for the research. They themselves give the chain The next you smoke, who is your friend who smokes and lives in the same atmosphere. Then the next selected person may point out another friend or another person who lives in the same atmosphere. So a friend recruits a friend who recruits another friend. So the chain, one points out the next person who can be a candidate for the research, and the next selected candidate points out another one. So this is a useful procedure for the rate or hard to find hidden population. For instance, type 2 diabetes women with hyperthyroidism taking a particular drug, and those may be selected, and those who are diabetes and taking hyperthyroidism drug may be difficult. Then the chain is there. We ask those ladies in their families having the same problem, in their genetic makeup having the same problem, or maybe from the outdoor whom they have been meeting with the same problems. Then is obviously multi-stage sampling. In this, different ways are included, and different types are included to finalize the selection. How it is done? A multi-stage sample recognizes that one who conducts study may choose different sampling procedures at different stages. For instance, select rates via simple random sampling. First of all, select slates. Then stratify districts in chosen. First of all, say for example, we select Punjab, Sindh, Balochistan from simple random sampling. Then stratify districts in chosen states by rural and urban for stratified random sampling. Then obviously we divide them into two, rural and urban areas of the province, and that is done for the stratified random sampling technique. Then select every fifth school systematic within the list of the districts chosen. Now we selected certain districts, and from there we select every fifth school from the list given of those districts. Then draw intact classroom randomly from the schools chosen cluster. That will be a sort of cluster sampling. So we can see that going through the simple random sampling, then stratified sampling, then obviously systematic sampling, and finally we go for the cluster sampling. And finally test sample. Every child is in those randomly drawn classroom, still part of the cluster. So in all those ways we go for the different techniques to select the sample, and that will involve different ways: random sampling and non-random sampling, non-probability and probability sampling, and of course it is called multi-stage sampling. Now after concluding knowing these different sampling techniques, error in measurements of the disease, error in measurements of the research, errors in the final measurement of the research done. So in all scientific projects, one must be concerned with the possibility of error in the measurements being made. So what we measure, what measurements, what outcome, what results are coming, there may be a sort of an error in those. So there are two basic kinds of errors. One is the random, that is by chance, and second the systematic, that is bias random. So chance error in the measurement, or the bias or systematic error in the bias or the systematic error in the measurement of a disease from the research. So random error first, by chance. Random error. So random error is the variation in the measurement that has no apparent connection to any other measurement or variable, generally regarded as due to a chance, somebody making a mistake, a human element, other elements, the calculation fault, but not done by any means with the intention, or any means with the negligence. It's only a chance, maybe a human element, or a sort of a we can say a sort of a just a random mistake. Then is the systematic error, also known as the bias. Bias often has a recognizable source, a faulty measuring instrument or pattern. It is consistently wrong in a particular direction. Of the two sources of error, systematic error is generally more important, the more insidious and more difficult to measure then the random or the chance error. Then is the systematic errors, bias or bias as it's called, bias, the systematic error in the study that leads to the distortion of the results. The results are distorted, we are directed away from the correct situation. The bias is the deviation of the results or inferences from the truth or processing leading to such deviations. The bias occurs as a result of flaws in study designs, collection, analysis, interpretation, publications, or review of the data that can lead to conclusion. Those are systematically different from the truth. So systematic error or bias can be of those types as far as the collection of the data, analysis of the data, interpretation of the data, or publication or review of the data that can lead to the conclusion. Those are systematically away from the truth. So we discuss them one by one. Systematic error, bias may be, first of all, design bias. The difference between the true value and that actually obtained occurring as a result of faulty design of the study. We implemented the wrong way of the study. Sometimes, most of the time, the things are overstepped as it's a human element, and the design bias has resulted into the systematic bias or the systematic error. So first of all, systematic error is the first type of design bias. Then is the bias in handling outliers. Bias in handling outliers. Errors arising from a failure to discard an unusual value occurring in a small sample 1 or due to exclusion of the unusual values that should be included. Certain unusual values are very, very much important, but unfortunately we discard that, looking at it is unusual, or sometimes some unusual value has been included which actually was unusual and has distorted whole of the result. So first was bias, design bias, then is the bias in handling outliers, then is the bias due to instrumental errors. Very much common in this part of the world, instruments being used, the refurbished or second time used, or used ones, or the faulty ones, instruments are used, the faulty techniques applied over the instruments. So the systematic error due to faulty calibration, inaccurate measuring instruments, contained reagents, incorrect dilution, obviously for faulting technique, or the mixing of the reagents. So all those may be because of the may lead to the bias, and the bias is due to the instrumental error. Then is the interview bias due to interviewers' subconscious or even conscious gathering of the selective data. Sometimes we want to know what is present in our mind. We do not listen to the facts being told by the participant. So first was the design bias, then is the bias in handling outliers, then is the bias due to instrumental errors, and finally, and now the interview bias, and now is the lead time bias. Lead time bias, what this bias is, when follow-up of the two groups does not begin at strictly comparable times. This occurs especially when one group has been diagnosed earlier in the natural history of the disease and then the other group. And what we do is we collect the data from one group earlier and then collect the data from the other group at a later stage. And sometimes in that case the result may not be, the data may not be correct because the other group has been improving as far as the disease is concerned. So that may be another reason of the bias. So lead time bias is the other type of the we can say the systematic bias. Then is the observer's bias. Observer has got his own opinion and he sometimes inputs affects the results by inputting his own feelings. So systematic difference between the true value and that actually observed due to observer's variation. Observer variation may be due to difference among the observers. Inter-observer variation may be there. There are two observers, one has got different way of judging a result, and other has got different way of judging their own experience, their own education, their own way of thinking about the things, or to variation in the reading by the same observer on separate occasions. One time he thinks different, and when he gains certain other knowledge, goes to the other people, gains the knowledge, now he has got, she has got certain other opinion about the result. So that is inter-observer, or maybe observation by the same observer, distorted observations by the same observer. So that may be observer's bias. Then is the bias in publication and editorial partiality or preference for publishing particular findings. Sometimes we are forced to publish certain findings which are not correct to the data. Sometimes we feel that as this finding was in United States of America or England, how we can differentiate or distort or go away from this type of finding. So we may be forced to find such results. So positive results which lead to the failure of the authors to submit negative findings for the publications or failure of the journal editors to accept and publish reports with negative findings. Sometimes certain things may be there, as far as nowadays it's very much such type of bias is there as far as the poultry food is concerned, because poultry food is damaging to the health, but as it's a very much big industry in whole of the world, people from different sectors are trying to publish such things which will obviously indicate that this poultry food has been very much damaging to the health of the mankind, and that may be the reason of all those heart attacks and other earlier deaths of the people. But as far as the journal editors or the publishers or the people in the media are concerned, they do not accept such results because it's a full industry. The industry will fall if such publication is there. Then they do not allow, and that may lead to bias in the publications. Then is obviously recall bias, error due to differences in accuracy or completeness of the recall to the memory of the prior events or experiences. Sometimes people do not remember what happened previously to those people, and they are not in a position to tell us the correct story. Sometimes they do not recall. They may not be liars, or they may not hide themselves, but they do not recall it correctly. So that may be again a bias. Then the reporting bias, selective suppressions are revealing of the information as far as the sexually transmitted infections are concerned. People sometimes hide themselves, do not report correctly. Then the sampling bias, some sample is selected is bias. Then the selection bias, those selected for study are not true representatives of the population, as we all know. So that may be again part of reporting bias. Then is the systematic errors. The systematic errors arising in the assessment of the outcome due to human element may be from three sources. So after knowing all the biases, as we all know, the first was of course random or by chance bias, and that was human element. Then was the systematic error or bias, that was the machinery bias or the instrumental bias or systematic bias. And the types of systemic bias were, first was design bias, then was bias in handling outliers, bias in due to instrumental error, interview bias, lead time bias, observers bias, obviously bias in publications, bias, recall bias, reporting bias, sampling bias, selection bias. Now is the systematic error, assessment of the outcome. That is again systematic fault or error in the measurement of the disease. So error in the measurement of the disease may be because of the assessment of the outcome due to human element, may be from three sources. This assessment of the outcome. First, there may be a bias on the part of the participant, who may subjectively feel better or report improvement if they know they were receiving a new form of the treatment. They are given the treatment, they are not improving, but they themselves feel they are improving, and they may report wrongly. So that is bias on the part of the participants. Then secondly, there may be observers bias. The investigator measuring the outcome of a therapeutical trial may be influenced if they know the particular procedure or the therapy to which the patient has been subjected. Thirdly, there may be a bias in evaluation. The analyst may subconsciously give a favorable report of the outcome of the trial. In order to reduce those problems, there are masking technique is adopted. So the sort of the bias, I can say, sort of the bias comes from the participants. One, second comes from the observers. Third, maybe in the evaluation. So to mask those mistakes, to avoid those mistakes, masking technique has been avoided. In order to reduce those problems, the blinding or masking techniques are adopted as far as the evaluation of the measurement of the outcome of the disease has been, or outcome of data collection has been done. So how masking is done, which ensures the outcome is assessed objectively. So this is done in three ways. First of all, single blind trial. Single blind trial means the trial is so planned that the participant is not aware whether he belongs to the study groups or the control group. So that is a single blind trial. Then is the double blind trial. In this trial, neither the investigator nor the participant is aware of group allocation and treatment received. So both the investigator and the subject, the participant, they are not aware whether they are in the control group or they are in the study group. Then is third triple blind trial. Here the participant, investigator, analyst of the data, all those are ignorant of the trial. The participant, the investigator, the analyst, everybody is ignorant to which system they go, which part they go, which group they belong, whether to the study group or to the control group, and that will obviously minimize the error, the systematic error, or the error in the measurement of the outcome of the disease or the data. So the double blind method is used most commonly in such type of researches. We continue with the applied epidemiology. Maybe in 1 to 2 lectures we'll be able to finish all those talks, and then we pray for your success. Stay blessed. Goodbye.